And now we have lightning talks. Talks that you could fit in a tweet, but let's give you 5 minutes instead. And with that, I'll hand over to our lightning talk czar, Christopher Neugebauer. He was just up here.
Veronica, you in the room. Veronica. Put your hand up if you're here. Is Veronica Hanus here? Oh. Okay, I'll put it later on. Sam Bishop, are you in here? Put your hand up. Wonderful. Okay, so now we can probably make a start. It's lightning talks time. Hooray, this is my at least second favourite bit of PyCon Australia. Can we have a round of applause? Stop! Okay, I need to train you. So lightning talks, they are 5-minute talks that can be on any topic a presenter wants to talk about. That can be about Python, it might not be about Python. We don't have a whole lot of time to get through these, so I'm going to spend as little time on stage as possible, hopefully just handy between our two presenters. So when I say somebody is on deck, you should come up and set up your laptop so you're plugged in and ready to go when the next presenter or your previous presenter finishes. And also, to make sure that we don't use up too much time, we need to keep our applauses nice and sharp and short. So I'm going to help you stop applauding. Everybody, please applaud. Stop. So good. Okay. We also only have 5 minutes per talk, and we want to help people know that their time is about to run out without drowning them out by applause. And we do that by applauding with our index fingers together. We can just about hear that. If more of us do that, maybe everybody could hear it. Wonderful. And we'll start doing that about 5 seconds before the talk finishes, and then start into a wonderful round of applause, and then stop. Great. Okay. I think Sam is set up now, so we are going to start with Sam Bishop, who's going to talk about computational world building. Sam, Mike.
It's green. Is it? Okay. Most of us at some point have thought about making a game. It seems to be almost universal that programming leads to tinkering, which leads to various experiments like trying to make little games. And along the way, most of us trip over procedural generation. I tripped over it fairly hard recently, not because I was trying to make a game, but because I started looking into trying to write more. And as part of the process of developing fiction, I went down a bit of a rabbit hole and effectively nerd sniped myself. Python is really good for this kind of thing because you can use it very flexibly to do lots of repeated little things, and generating procedural content is like that. So there's actually a lot of really good examples of using Python to do generation of things, and it gets more complex as you look into these things as well, including things like a spaceship generator that automatically generates them in Blender for you. And tools like this, which is a Python-powered nodal editing system in Blender to allow you to build up objects procedurally as segments and computationally construct them. And right up to planets, which I'll give a demo of here in case Blender's giving me grief, but we'll see if it actually renders. And that's actually being rendered as a real-time shader using Blender, which is, in case you don't know, built with Python and scriptable with Python. So even if this is actually using some of Blender's other parts, I can dump that texture and use it for something else that I might want to do. Like, for instance, I might want to work out what the climate of this world might be like. And it turns out there's good Python libraries for doing that as well. There's ISCA, which is a computational model for building global circulation of planetary atmospheres. It's all in the blurb. And they've got some lovely diagrams here of what you can do with it, including defining a little terrain section that you can see there with a big square blotch or the weird-looking continents on the right there. And then it'll generate what the actual climate's like across the planet. And so as I keep going down this thing, I start experimenting with building planets. And so I'm building physics, I'm building equations, it's turning into a weird pile of physics and math. And then I trip over an article that thoroughly snipes me. There is this article by an actual planetary scientist. He does do celestial mechanics for a living. And he was writing about how many worlds you could fit in a solar system. And then he found a 30-year-old research paper. He sniped himself a little bit there, but I think it might have hit me in the recoil. Because after discovering this, and then his follow-on, which was how he managed to put 9 stars and about 1 million Earth-sized planets inside the one solar system, I was a little hooked on the concept. And so I started trying to work out what it might be like. And as you do, I've got a piece of software that'll tell me what a planet is like, and it needs some inputs. So I start trying to generate those inputs, which means I need to work out how much light is going to land on there. So I start working out, okay, where are my stars going to be? And then after I've worked out where my stars are going to be, I'll work out where their radiating patterns are and their shadows, and I'm doing the math, and I'm doing the math, and I'm doing the math. And then it doesn't work. And it doesn't work quite impressively because let's see if version number 7 has finished rendering. No, it looks like 7... Yep, 7 has failed on me as well. So the 7 version does work. The one you saw there was 8. This is using 8 stars, and for some reason this doesn't work. But it does work for even numbers if NumPy doesn't give me grief. And then it goes on further with these things because this actually took... I'll find the number here for this one. The hard part of this took a... Where are my timing markers? Oh, let's remove my times. Well, I actually let that one run overnight on a cloud server. Because apparently computers aren't very good at abstract numbers. They're great when you have a number that actually means something, not so much when you have a number that could mean anything. And so this sort of thing takes a much longer time for the computer to work out, which was fairly surprising to me because I can do algebra on a piece of paper faster than some of these things can. But I definitely wouldn't want to be doing trigonometry like that. I know where my limit lies.
Is that the end?
Yeah, that's the end.
Wonderful. Thank you, Sam. Okay. Is Genevieve Buckley in the room? Wonderful. Great. So for our coming up, our future presenters, if you have dongles for your laptop, if you can bring those up on stage, we do have some spares, but we don't want them to go running around too far. Before Genevieve, we have Veronica, who is going to talk about code comments.
All right. I hear one person say yes. That's exciting to me. OK, so we're going to do this really fast. How many of you all have written a comment to yourselves like within your code? Oh my God, I'm in the right room. Yes. OK, so there's lots of reasons to do that. We could spend time on that, but we won't. And instead, I'm going to tell you, so when you wrote that comment in your code, did you think that what you were writing was documentation? Yeah? No? Looks like no. OK. So as you can see, documentation plays an important role in the usability of our code, and it's fairly important. And I would like to challenge us all to start thinking of those inline comments as their own form of documentation. So comments as docs have different benefits than these long-form readmes that we think of as documentation. They may give a why for a decision. They're lowering our cognitive load. They're describing our functions in place, perhaps. And so with all these good things that comments do, you may think that we'd be throwing them everywhere. But what's the problem with that? All this is actually true. So the testing may point us to outdated comments, but there's nothing that I've found to keep these comments up to date. So these comments do point to unclear code. And given that, if these comments mislead, this comment takes on an even more important role in what we think of as comments. But with write the docs on one side of our shoulder and keep it dry on the other, it's kind of hard to decide what to do. So we're going to look at some ugly code that I wrote with some ugly comments. Get excited. And so here I said at the top of the doc, hey, I used a tutorial to do this. It's kind of important that you know that I didn't start out with this code. But here things got a little more complicated in this second example. I wanted a little notification to pop up when a climbing wall near me was open. So I used Beautiful Soup, and that was lovely, but I'd never used Beautiful Soup before, so every time I got confused, I wrote myself a comment. I saved code that I shouldn't have saved, and I wrote my favorite comment to date. Oh, it's a list. Thank God. Oh. very complicated relationship with comments. There are some best practices we can agree on. We all know that outdated comments comment in the form of filthy, dirty lies. There are some things that we have a little more contention about, and all this confusion means that we sit here and we make ourselves memes. You know, when you feel strongly about something, you make a meme, right? So like maybe comments are a waste of time labeling cats, or maybe, you know, the only bad code is the uncommented code that won't be useful in the future. Now, of course, the internet has a lot of really helpful advice. We could refactor, we could just code better. The bottom line, the internet tells us, is only our code matters. Now, I don't know what this sounds like to you, but it sounds a lot like, to me, like there's a screaming squirrel telling you that you must stop, but not telling you what to do instead. That's what it sounds like to me. So as we know, we have some advice coming our way. And you know, when I look at that, I hear the way you learn is an anti-pattern. And you see on the internet a whole lot. This is from Stack Overflow, lo and behold. People ask really thoughtful questions. Oh, I'm in this situation, I'm trying to comment, I'm thinking about it this way. And they get really helpful answers like this. This has been discussed to death. You know, go to this blog post that I wrote. And you know, when I hear that, I don't know what you hear, but I hear, your struggle bores me, and you are a bad programmer. Okay, thanks, bye. And so if we can go back and remember our first comments, we can remember that they're magic. They're a lifeline. They really help beginning programmers and programmers at all levels. So I've seen, especially with new programmers, use comments in a lot of different ways. And I want us to remember, as we're evaluating how comments should be used, that a lot of us are in that position. I committed a lot of stuff to Git. I really don't know what I did tonight. I really need some more comments in my life. We're going to skip this slide because the story isn't as important as the time. So I started asking everybody about code comments, and I tried asking Twitter. And you know, a whole 6 people responded to me because I have such a good following there. And I said, wait a minute, that doesn't give me very much data. I'm so sad about this. But apparently there's about a 50-50 split among those 9 people. So let's do a real survey and ask more questions. So there are my questions from the real survey, which we will not go through today because that's how life is. And so I asked, okay, so we're going to go real fast. So a lot of people feel positively about comments in the following ways, but when we get to the point where I have to ask, hey, code is self-documenting, they say this.
Thanks, Veronica. Sorry, we're really strict on time here.
Yeah, I got it.
Alas. Okay, William Brown, you are on deck. But first, this is Genevieve. She's okay. She's going to write Python the lumberjack way.
Thank you. Yeah, with logging, get it? So slides are up here, code examples, take a picture if you want. We're moving on pretty fast. My name's Genevieve. I'm a scientific programmer. I work, we're doing data science for biomedical research applications. And if you get super inspired by this guide for the, extremely short guide for the bewildered and the befuddled, you can check out some of these more advanced tutorials or get your feet wet in a more a bit of a better way. But this is for you if you have never logged things before. Why would we want to do that? Logging is part of the standard library, so it's super easy, super useful. You can check out the docs here. And there's a number of advantages of using logging instead of just littering your code with print statements. This is particularly important in cases where, say, I have to write a script or a program, an application, and I need to then give it to someone else, some users to use. I ran into, oh gosh, IT problems. I ran into a friend of mine on the bus the day I came to PyCon, and he told me that actually he's written some Python scripts being run by, can we get IV help over here? He's written some scripts. They're being run by some people that he knows, and it's not working so well for him. They tell him that in about 10% of the cases, it's broken. And how long has this been happening? Maybe a couple of months. That's not something I want to debug, especially not with logs. So there are a number of advantages we can have over printing. You can log to the file, as well as the terminal simultaneously. You can easily change how verbose the output is with just a single line rather than having to redo all of your print statements through the code. And if you log the user input as well as the exceptions and the stack traces, you can reproduce those issues later. So that's really critical for me. So how can we use it? Just real quick, let's have a look at an example. So we can use logging's basic config to set our logger up. Here we can see that there's basically 3 lines to it. There's a format, and so my logging messages will have a timestamp. They will have the priority level of the message, and then they'll have the message, like what I want to convey at that point. The level we have next is setting the priority level for the logger. So debug is maybe our most generous level. We're going to see everything that has a logging call. And then the handler that I've set here is a stream handler. That just means I want everything just printed out to my terminal when I run this. So if we then have a little look at that, so here, this is where we would maybe take some things that might be originally print statements and instead write logging.info. Some useful information here. Logging.warn. That's a stern warning not to do that. And we can see them being output to our terminal at the moment. If I want to make my logging less aggressive, I only want to be told about warnings and above, really critical messages, I can do that with a single line change and just set that priority level. So now we see that everything that is unimportant in this use case is just being ignored, and we're happy with that. So that's nice, but we really kind of want records of this. So we want to log to the file and the terminal simultaneously. And that's also super easy. It's just a 1-line change. We can see in the handlers list, we have our stream handler like before, but now I've added a file handler as well. So it's, the logging output will also go to the file name that I've specified here. So let's run something similar again, have some nice messages. Okay, that's cool, but what's in the file? We can see. So by default, logging will append to the file, but if you don't like that, you can change it with file mode. And if you want to log different priority levels to the terminal versus to your file, you can also do that. There's a good example in the cookbook. So logging exceptions is hugely, hugely useful. You would do that something like this kind of syntax. If you use the logging.exception, you will automatically get useful information there. It's equivalent to logging.error with an exit.info equal to true. But if we want to log uncaught exceptions, you can do kind of hacky things and connect a handler to sys except hook. That won't work well in the Jupyter notebook that I have going here, but that's a fun kind of thing to do. This isn't an excuse not to raise and handle your exceptions properly, mind, but when things go wrong in unanticipated ways, we really want to know. Cool. So, thank you very much.
All right, thank you, Genevieve. So when we put up the call for lightning talk proposals, we said that your talk didn't have to be about Python. William has given me on deck, Rowena Stewart on this side. William has given me a really descriptive title here. It says History and Politics.
Thanks, Chris. I'm here to talk to you today about history and politics of Australia and New Zealand supermarkets and their subsequent mergers and rebrandings. This is Australia, and this is New Zealand. Now, we have supermarkets in both of these. Australia has a duopoly with a couple of small independents, and New Zealand has a few major brands of its own. How we got here is a journey that takes us over 105 years of history. 1914, Coles was founded in Collingwood, Melbourne by Sir James Coles. At around the same time, Foursquare was founded by John Barker in New Zealand. Foodstuffs Auckland was founded by the Master Grocers Association to create a cooperative buying group. They expanded in 1925 with the introduction of Foursquare branding on all their members' stores, something unprecedented at the time. Well, Foodstuffs Wellington saw the success and said, we'll make another one. which is independent to the Auckland Foodstuffs, has its own board of directors completely separate. Now, Woolworths Bazaar was founded in New South Wales, and it was named this because they were worried about issues with American companies invading. But when finding out that America was not going to invade, they called themselves Woolworths Stupendous Bargain Basement, followed by rapid expansion throughout most of the states excepting Tasmania and Western Australia. At this point, Foodstuffs Christchurch is formed, again independent to the other two. Meet Frank Lindstrom in 1930. He decides to make a supermarket and then sells it very quickly to Woolworths. We'll come back to good old mate here soon. 1940, Woolworths has a store in every state of Australia after finally opening in Hobart. Sorry Perth, not enough space. Frank Lindstrom is back. Now he starts Franklin's in New South Wales. This guy is Bill Pratt. He starts a market chain in Frankston, Victoria called Pratt's. Dunedin opens their own foodstuff cooperative, making it the fourth in New Zealand, all independent. Progressive Enterprises is formed in Perth by the Pico family. They aren't a supermarket, but we'll come back to them. Rolf Voss turns his milk bar into a self-service market. And then a store called Dickens exists in Victoria. Coles buys all 54. Food Town is now created in Otahuhu in Auckland, and supermarket in South Australia called Bilby's is also claimed by Coles. 1960, Coles decides to buy all of Matthew Thompson's in New South Wales. Progressive Enterprises now decides to buy out Food Town in New Zealand, and Coles is new branded to Coles New World, which has no relation to New World in New Zealand, which doesn't exist yet, by the way. America is invading, and that's Safeway. Safeway buys all three of Pratt's stores in Victoria. And at this point, New World does exist in New Zealand as part of Foodstuffs, which has no relation to Coles New World as mentioned. Bilo is now founded in South Australia at around the same time as Countdown launching in 1981 in New Zealand as part of Rat Race Wholesale. This guy, Mr. Franklin's, is started to open in Victoria. And at this point, Woolworths decides to play Katamari and gobbles up Rolf Voss and Purity in Tasmania. Franklin's finally opens in Queensland, we're a bit slow. Safeway now owns 126 locations in Victoria, Queensland, and New South Wales, except for in New South Wales where they're called Red S due to a possible trademark issue with Saveway. Pack and Save is founded in New Zealand as an imitation of Safeway, and Woolworths plays Pac-Man, acquiring Safeway, rebranding New South Wales, but not Victoria, where Safeway becomes the fresh food people. Coles now buys Progressive Enterprises, therefore acquiring Food Town in New Zealand, and Franklin's decides to open in South Australia and ACT. Coles in 1990, the most fashionable decade, let's face it, Coles New World rebrands to Coles Supermarkets. And at this point, Coles says, no, I'm sick of you, Progressive Enterprises, and divests. At this point, PE still owns Food Town and Countdown New Zealand. Coles Supermarkets now rebrands to Coles, and it's the year 2000, known better for the Sydney Olympics. Woolworths, however, start to rebrand everything, including Rolf Voss and Purity, and at this point, Progressive Enterprises buys Woolworths in New Zealand, followed very quickly by Woolworths Australia buying Progressive Enterprises, which now owns Woolworths in New Zealand, and now Coles purchases Bilo in South Australia, leading to hilarity such as a farm with two Coles within 15 metres of each other's, and both still operate today, and legend has it there's more around the country, find yours. Woolworths, Progressive Enterprises announces all Food Town and Woolworths will rebrand to Countdown, leading to situations like this, where suddenly it changes overnight and people don't know where their supermarket is. Franklin's decides to become IGA, Food Town is finally rebranded at Bounds Bay as the last one to Countdown, and Foodstuff Auckland and Wellington merged to be Foodstuff North Island, separate to Foodstuff South Island, which was a merger between Dunedin and Christchurch. Woolworths starts and nearly completes their rebranding of Safeway to Woolworths in Victoria in 2013. However, the final Safeway in Wodonga was rebranded in 2017. And that's how we got here. 105 years, 17 different businesses, eventually becoming 6-ish. Thank you very much.
What's funny is that was exactly what was promised to me. Unfortunately, yes. Damien, George, you're on deck, but first, Rowena Stewart.
Is my microphone? Yes, my microphone is on. Okay. Hi, everyone. I'm Rowena. I am a software developer, and I'm also a co-club volunteer. So Co-Club Australia is a network of volunteer-run clubs with the mission of giving every child between the ages of 8 and 15 the opportunity to learn coding. I've been facilitating a club at my local library in Eastern Sydney for 3 years now, as well as running school holiday sessions at my workplace. Throughout Australia, there are 2,300 clubs reaching approximately 45,000 children. On the website, there are 140 hours of free lessons, including content in Scratch, Python, microbit, HTML, CSS, and 6 modules using the Sense Hat. The most popular being the Rainbow Predictor module, which I will be showing you today. So, what is a Sense Hat? Hat is short for hardware attached on top. These are add-on boards for Raspberry Pis. This one has got a whole bunch of sensors on it, therefore it's called a Sense Hat. It also has an 8x8 LED array. So, what does the Sense Hat sense? Humidity, barometric pressure, temperature, acceleration, orientation, and magnetic fields all in one chip. And it's got a joystick for input. But not everyone can afford a Raspberry Pi, let alone one with a Sense Hat on it. Sense Hat costing almost as much as the Pi itself. Thankfully, there's an emulator on a website called Trinket.io that also with a 3D module that you can drag around. And kids usually spend the first few minutes of the lesson doing exactly that. You can use the sliders at the top to manually change the sensor values, and you control the joystick with the arrow keys of your keyboard. So, on to making rainbows, which is the title of my talk. First, we define each of the colors of the rainbow using an array. It's an RGB array, and it's great for teaching kids about how computers represent colors. Next step is to compose the 64 value array to represent what color to make each LED in the array on the actual board. And then we use the set pixels function to actually turn the lights on, like this, or this. So the next step is to get some data out of the sensors. For this, we'll only be using the humidity and the temperature sensors. So we say if it's high humidity, which we define as over 80%, and high temperature, which we define as over 20 degrees Celsius, we show the rainbow. If it's humid and cold, we get snow. If it's hot but not so humid, we get sunshine. So this is also great for teaching kids about science and the environment, that's the word. You'll see on the line 7, we're passing a value into sense.clear. This is really counterintuitive because you're trying to, normally you'll clear the screen. So what this does is it makes all of the LEDs that one color. If you don't pass it any values, like on the last one, it clears the screen. So why don't we see what the conditions are like in the room today, particularly this area of the stage. So I could scroll text. That's temperature, 26 degrees Celsius, and then humidity, 40%. So following that code, we should get sunshine. Ta-da! So that's the end of my talk, more or less. Code Club's really fun to do. You should all do it. There is a map on our website, on the Code Club website, to find the nearest club. So you can do more cool things with Sense Hats and Python. You can start your own club. There's also online training for volunteers. I will have this with me tomorrow if anyone wants to ask me about it or have a look at it. And thank you for listening.
Thanks, Rowena. Okay, Gavin Smith, you're on deck on this side. But first, we have Damien George, who's going to talk about Fermions.
That's right, yes. Hi, everyone. So I'm Damien George. I'm the creator of MicroPython. You may have seen me talk before, but I'm not talking about MicroPython today. I'm not even talking about Python. I couldn't connect this to talk to Python in any way, sorry. I'm going to talk about elementary particles. So in a past life, I was a theoretical physicist, and I worked on the Standard Model and the Higgs boson and some string theory-related physics, which is all very interesting, although Python is much, much more interesting than that. And what I'm today, I just want to explain a little bit about the elementary particles of the universe. I think they're very interesting. So this is a periodic table of the elements, which is what most people think of elementary, hence the name elements. So everything in the world is made up of these elements. But these themselves, like hydrogen, helium, and so on, are made up of other things more elementary. And this periodic table here is, the layout of the table is actually important. And you can derive the layout of this table by doing some physics, like solving the Schrodinger equation. And what I'm going to try and explain is what these particles are made of and how you create a periodic table of the more elementary particles. So there are two kinds of elementary particles. Fermions, which is, I have written that the wrong way around. Fermions are the hard thing, like wood, and bosons are the soft thing, like light and gravity. And they're the two basic elementary things, and everything is made up of them. And usually you can see a picture of these like this. If you Google the standard model or something, you'll come up with a picture like this, which has the fermions on the left, which is the green and the purple, and the bosons on the right. So on the right, there's the gluon, the Higgs particle, which was recently found, the photon, which is light, what everyone knows about, and the W and the Z at the bottom is there for nuclear decay. And on the left, electrons, neutrinos, up and down quarks is what everything is made of. Now, the key here is that you can arrange these particles in certain ways, like the periodic table of hydrogen, helium, and so on, so that you can more easily kind of understand the structure of the structure of the universe, the structure of the elementary particles of the universe. So this is a plot that I made for my PhD thesis a while ago. And it shows the charges of the fermions, of all the hard things that everything's made up of, in a neat diagram. So you can think of this like the periodic table, but for the quarks and the electrons and neutrinos. So I'll try and explain it a little bit. On the left-hand side, let's start with the electron. So the electron is actually made up of a left-handed part and a right-handed part, EL and ER. But they are actually separate things to begin with. So the right-handed part of the electron is known as a singlet under SU2, and the left-handed electron is part of a doublet with the left-handed neutrino. Now, what happens? So the right-handed electron has charge -2 on this axis, which is the U1Y symmetry, and the left-handed doublet here has a charge -1. So that's why this is a picture of charges and why things are arranged as they are. Now, to get to reality, the Higgs boson comes along and it breaks the symmetries that you see here. It breaks the U1 and the SU2 and it mixes them together. And it takes a linear combination of them. So what you're supposed to do is then look at this picture from a slant. Now, the Higgs is like, you don't want to go that way, you want to go this way. So yeah, if you slant to the left, like that, that's the way you should see it. And so what it does is it mixes things together. So the left and the right-handed components get mixed together here, and you see the electron in real life. So looking in that direction there, along that line, you see the true electron, which now has mass because of the Higgs and because of this mixing and this angle. And it has charge -1. We know the electron is charged -1, as in it's negative. And so you've got to look along diagonally. So -1 is down here, and the positron has a +1 charge, which is on the other side. And in the middle, along this line, is 0 electric charge, which is the neutrino. So the neutrino is chargeless. And the up and down quarks have +2/3, +1/3, and so on. These little 3 dots mean they're charged under QCD color, so they can bind together to form nucleons. So 2 ups and a down make a proton, which has charge +1. And, 2 downs and 1 up make a neutron, which has no charge. So you can do the math to see that. Thank you.
I drifted off there. Was it Woolworths who acquired them?
No, IGA.
Ah, yeah, okay, yeah. Always forget about them. Jason Giancono, you're on this side. But first, Gavin Smith, who is
robots and dinosaurs.
Going to make a machine go ping, apparently.
Okay, g'day. I'm Gavin. In my spare time, I help run the Robots and Dinosaurs Makespace in Meadowbank. I'd like to talk to you about robots that make things for you and tell you where you can find robots that make things for you and some tips about how to make the robots make the things that you want most effectively. So to start with, we are living in the future. Rapid prototyping is a thing. What exactly is it? It's robots that make things for you. So to give a simple example of this, laser cutter. It's a robot. It moves the laser, cuts and engraves the material for you. Another example of rapid prototyping is 3D printing. The robot artfully moves plastic nozzle, lovingly spews the plastic onto a surface for you in a shape that you've requested. If you're very lucky, it matches what you actually fed into the machine. CNC machining. A robot moves a spinning drill bit, removing bits of wood that you don't want anymore. These are essentially the three main ways of getting rapid prototyping working. That's great, but where do you get access to these things? Not many people can own their own laser cutter and 3D printer and CNC machine. I did previously, but I don't anymore. So, because makerspaces. So rapid prototyping is expensive. We can't own every machine ourselves. Luckily, makerspaces are a thing. Find one in your city. What are they? They are a community of people that like making stuff. What sort of stuff? Just techie stuff? No. Anything. We've got people that do glasswork, electronics, laser cutting, sewing, woodwork, programming, casting, etc. Definitely not just traditional tech stuff. And if you've ever puzzled on a problem and spent a day trying to figure out how to do it, and you want to be around a bunch of other people that have also spent time pounding their heads against problems, this is the place to go. First-time visitor to Makespace, please watch out for what I call the "we're not worthy" effect. So people walk into a Makespace and they see someone doing woodworking, they see someone doing electronics, they see someone doing casting, they see someone do this, and they go, oh my God, I only know how to do one or two of those things. I'm not the person who belongs here. But if you walked into a library, you wouldn't see someone with a book on Greek literature and a book on art and someone studying surgery and think, oh my God, these people know how to do all of those things. So no one person does everything. So just watch out for the "we're not worthy" effect. It's really, really subtle, and yeah. Anyway, so here's some practical suggestions. So makerspace is a thing, go find a makerspace. Here's some practical suggestions for what to actually do with them. In my humble opinion, laser cutting, if available, always beats 3D printing. You get a result in 10 minutes versus 4 hours. There's way less tweaking of temperatures and maintenance of the machine. It allows you to make mistakes so much faster. No design ever works perfectly on the first go. It needs 1, 2, 3 times to get it worked out. If you've got a laser cutter, you can get it out faster. Here's a few bits and pieces that I put together just in a few hours. It's very, very satisfying to have a concept and then go to actual thing in a short amount of time. I'm running short of time. Python, there are Python generators for SVGs and STLs. That's for laser cutters and 3D printers is the most dominant file for each of those respectively. Also, everyone uses Jupyter Matplotlib. Yeah. You can make Matplotlib save a plot as SVG and then throw it directly into a laser with maybe 1 or 2 minutes of coddling in Inkscape first. As a quick example of that, here's sorting out a friend's thread collection. Has far too many fabric-y things just in terms of storage space. This is a way of imposing organization on that. And now, please note, you've now got first-order access. You can see all the stuff and you can grab it in one go, whereas before it would have taken you 10 minutes to figure out whether you've got it or not. A second example, just real quick, Feynman spiral. Feynman did his intro to quantum mechanics and used a double slit as an example. And I'm reading this, and he basically explains in a lecture why the 2D graphs don't work. And you need, for QM, you need to use complex numbers and not real numbers and blah, blah, blah. And he just showed equations, but he never did the actual plot. And I'm like, ooh. And I'm Googling around, no one else has done the 3D plot yet. And I'm like, okay, I need to do this. Make a Jupyter notebook, boom, here's the thing. And I'm very happy, but I want a tangible version for my coffee table, God damn it. So I modified the Jupyter notebook to make SVGs for laser cutting. There's a whole bunch of little squares there, glue, stack, paint. I now have a coffee table thing of the Feynman spiral ready to go. Makespace Hacknix is near you. Sydney, Robots and Dinosaurs, Meadowbank, first one there. Canberra, Make Hack Void, Melbourne, CCHS, Perth, Artifactory, Tasmania, Hobart, Hackspace. There are others.
Great. Okay, Bianca Gibson, you're up on deck on this side. But first, Jason Giancono is going to show us more Greek, apparently. Is that all?
Yeah, oh, what? Sorry? Yeah.
More slides?
No, this is it. Okay, hello. I'm Jason Giancono from the Australian Council of Trade Unions. I'm a software developer there. And I'm going to talk about monorepos. So there's a better talk than the one that I'm about to do, and it's by Rachel from Google. And it kind of goes into the benefits, pros and cons that they have with the Google mono repo. And I guess when I first watched that talk, I really liked all the pros, and a lot of the cons kind of only really seemed like they would affect Google because they have giant code bases, and like all the places where I've worked have been a bit smaller, and so didn't really have those kinds of issues. So I'm just going to go through like a common scenario that you have with like multi-repo workplaces. So like your company wants to build this app, it's called Appa. So they create a new repo, and then Appa has a feature that is similar to their other app called app.io. And so they're like, well, let's reuse that code. So they refactor app.io to remove as much of the code to do with that. And they put it into a third repo called FeatureX. And then they import that into both Appa and app.io. So now there's like 3 repos. Can I just see, like, has everyone had that kind of situation at their workplace? Raise your hand. No, don't? Yeah, okay, cool. It's not just me. Now, this is where the issue comes in, is when you try and make a change. So if I want to make a change for app.io, and that requires me to change FeatureX, I need to make a new branch in FeatureX and a new branch in app.io. Then I make the relevant changes into FeatureX and do a pull request into FeatureX. In the meantime, I update the reference to FeatureX in app.io, make the changes that I need to do, and then do a PR there. Then I go back to the other PR. No. And then I get comments on that PR, looks fine, get approved, but then I need to wait for the other PR to get merged. But then the issue is that someone comments on that PR, and then I got to make changes. So I make changes, push them, and then I got to go and update the app.io PR, push changes to that, then get the other PR merged, then go and update it again, because obviously before it was pointing not to master, it was pointing to whatever my PR branch was, and now you need to make it change to master. I've got to update it again, and then usually that means that anyone who reviewed it has to review it again, and it's just bloody awful. And then there's this last bit at the end where obviously Appa, which was the original app where the feature came from, I'm not really changing that app at the moment, but I've just changed something that depends on. And so if I'm really nice, I'll go through and update it and make sure it works. Or if I'm not, then I'll just leave it. And then the next developer who comes to update it will then like have this code that doesn't work, and then we'll have to fix all my issues that I just introduced. Any hands of if that's ever happened to you? Yeah, it sucks. Now, if we had everything in the one repo, all I'd need to do, update FeatureX and app.io, and then when I push the code, it would run the tests for anything that depends on FeatureX and also on app.io, and then you got one PR, one review, one merge. It's great. And so when I went to do this, I'm not expecting you to read that code, but I just wrote like a bit of a bash script to pull in all our repos, put them into into subfolders, each with the name of the repo, and then commit them. And that link is the gist of it. And it's crappy like bash code, but you know, it got it done. Then the issue is like your CI/CD. A lot of them are based on the idea of, you know, one repo, one build, one deploy pipeline. And so I had some issues there where, like, obviously before every time there's a commit to the repo, it will build that repo. But now you don't want to build literally everything when you do a commit. So you've got to check and see what files have changed, and then determine which tests to run and which deploys to run. And yeah, it can be a bit difficult, but it can also be done. Some CI tools are better than others. I found that with my particular CI tool that I won't name, the current API doesn't let you programmatically trigger builds, which means that we're going to have to switch CIs to get this working. But then there's all this cool stuff that can happen. So you remove those issues where there's fragmentation and different versions between projects. Big refactors are easy. You break down silos between teams and all the other stuff on the slides. All right, thank you, everybody.
I actually finished. I had a joke lined up and everything. It's terrible. Jim Mussared, you are up on deck. But first, Bianca Gibson is going to tell us how to become a 10x Rockstar developer.
So I've been a developer for a while, but I only recently got to the point of becoming a 10x Rockstar developer while right at this conference. So the first question to ask when trying to become a 10x Rockstar developer might be, what is one? What is a Rockstar developer? Well, if a Python developer is a developer that writes Python code, then it makes sense that a Rockstar developer is a developer that uses the Rockstar programming language. And there is a Rockstar programming language. Rockstar. Rockstar is a computer programming language designed for creating programs that are also hair metal power ballads. And here is an implementation of FizzBuzz. But just going with the FizzBuzz example doesn't get me to 10x Rockstar developer. And I would prefer to write it in a genre that I can also play to some extent, like I can play guitar for, because then I'll be a more well-rounded Rockstar within that area. So I implemented something that takes a number and multiplies it by 10, thus 10 times Rockstar. And I wrote the lyrics to be idiomatic for one of the genres that I can play on guitar, psychobilly, because that gives me a bit more range of themes to work with. So idiomatic lyrics include tales of gargoyles attacking Copenhagen, and haunting the home of your partner that murdered you and watching them while they try to sleep and keeping them awake because you're staring at them with undead eyes and they're creeped out. Or rather than kissing a girl, you're kissing a ghoul. So Rockstar allows you to do quite a bit. I can't remember if it's Turing complete, but you can do a fair bit. So you can define functions and do some operations. And yeah, facilitates making them read like lyrics. So the first line, undead takes horror, so undead is the name of a function and takes, the list that comes after takes specifies the arguments. So horror is an argument. And then is used for assignment. And you can do, you can use words, doesn't have to be English, to provide the numbers. So in this case, zombie is the variable name, and then the two words, my girlfriend, specify the number. So it uses 2 from the number of letters in my, and then but it derives the number, and each word gives you a number, which is chained together to create 20 in this case, because it takes modulo 10 of girlfriend, so that comes out to 0. And then, I could have said zombie is a girlfriend, but that doesn't make much sense, so I had to say my. So then I had to subtract 10 to it to actually get the number 10. So ghost is a silhouette, gives me 10 because A has 1 letter. And so then puts zombie without ghost into hot rod, gets me the number 10. And also specifies that this random ghost that's hanging around doesn't come for a ride out to wherever we're going. And then give back hot rod of horror. Interpret that how you will, it's rock and roll. And life is an apocalypse, which in this case will give me 20, and to apocalypse, 10 letters modulo 10. And then scream, you can say scream or say or whisper for output, but since I'm talking about ghosts and zombies, scream seems most appropriate. So scream, undead taking life is then how it outputs the number 200. And if you'd like to learn Rockstar, they have documentation, a language specification, which you can go through. And there's also a variety of implementations, including a Rockstar to Python transpiler that you could have a go at.
Now you too can be a 10x Rockstar developer. E. Dunham, you are over here on this side. I can only assume you're deeply confused at this point, Jim, because it says on this, how does the moon work?
Hi, my name's Jim. I'm a self-confessed space nerd, but maybe not quite as knowledgeable as I like to pretend I am, as you'll discover. 50th anniversary of the Apollo moon landings, very exciting time for my people. To make this vaguely relevant to Python, I discovered that the Apollo guidance computer actually runs a virtual machine. It's unfortunately not the Python bytecode, because it was mid-1960s, but it is a VM. So there you go. All right, I would like you to please turn to the person sitting next to you and, as if they were a 9-year-old, explain how you think the moon changes shape. I haven't got long, so be quick, okay? First thought that comes into your head. Okay, stop.
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 All right. Did your answer make sense? Do you know how the moon changes shape? Did your answer involve the word shadow? Can you explain this picture? Do you know why I'm asking you this? When you say shadow, does it involve the Earth's shadow? Does somebody want to admit to saying it involves the Earth's shadow? Thank you, somebody. Okay. This came up because I was sitting on the couch next to my soon-to-be wife, and amazingly, eventually wife, and I said, "That's weird. The moon's a funny shape considering the sun just set on the horizon." And she said, "What is wrong with you?" And I said, "How can the Earth be casting a shadow on the moon when the sun is just over there?" And she said, "What are you talking about?" And I said, "I don't know." And she said, "What do you think an eclipse is?" And then she said, "What is wrong with the education system in this country?" She is a New Zealander. Okay, I've prepared an animation. To make it more relevant to Python, this was ray traced in Python in the performance test for MicroPython, which is used to test new boards and new builds. And it shows how the moon changes shape. A lot of you are nodding your head, of course this is how the moon changes shape. What is wrong with you? But for some people, notice the Earth's shadow is not involved. The moon is a ball in the sky. Sometimes it's lit, and we see one part of some angle of the lit side. Why isn't an eclipse? Some people think that the moon has an eclipse every month. It turns out the moon is on a 5-degree inclination from the ecliptic plane. So most times the moon cannot even be possibly behind the Earth because it's up 30,000 kilometers higher than the Earth on the ecliptic plane. Some people I've discovered have all sorts of reasons for not knowing why the moon works the way it does. And my son, unfortunately, had this experience that the first time he saw the moon, it was an eclipse. He was born on July 26 last year, and the first time we were able to actually be somewhere where we could see the moon, it was in eclipse, which I thought was pretty cool. If you want to learn more about the moon, the eclipse, the lunar cycle, and so forth, I highly recommend, wait, I should be presenting, these 2 videos from Matt Parker, one of my favorite YouTube channels, and then at the bottom, a cool video, which is how you can learn to tell the time looking only at the moon. I clearly learned nothing from this whole experience because only a few weeks ago we were walking home and I saw the moon and there was a bright star next to the moon. And my wife said to me, I wonder what that is, that bright thing in the sky. And I said, given almost this exact picture, and I said, that must be Venus. And she looked at me and said, what is wrong with the education system in this country? Thank you very much.
So, does the moon work?
There's a Woolworths on the moon.
Oh. See, I would have thought it was a Coles because of the logo and all that, but there's something wrong with the education system in this country. So we have more lightning talks tomorrow. Sign-ups for lightning talks will open sometime at the start of the day and we'll go through until the end of morning tea. There'll be submission boxes at Reggio or something like that. But of course, to have more lightning talks, we need people to speak. And Emily is going to tell you why you should speak.
So, I've been doing this speaking thing since 2014, and this is my 61st conference talk. Like, please stop, thank you. Like every speaker, I've given some talks that I thought were great, some that I hope to never think about again, and I've learned things from every single one. Do you think that you can't give even one conference talk? Yes. If so, I am here to tell you that you are wrong. You should speak. Why should you give a talk? Well, you benefit from speaking because you make new friends, you show off your work, and you tell others about the changes that you want to see in the tech community. Your company benefits because your talk is good for its reputation, your network that you'll build by speaking is good for its recruiting, and its name on your badge is free advertising. So tell them to help fund you if you need help getting to a conference. And the conference benefits from your submission to speak, even if you do not get accepted, because when the papers committee has more options to choose from, they can build a better program. Here's how to do it. What you should say and where you should say it are actually the same question. The best talk for you to give is something that you know about, and the conference needs, and the audience wants to hear. If you find a topic that ticks all those boxes, it might be a winner. Think about what you spend your time on and what you want other people to know about. Here's some free examples. Or if you've got two interests that you're average at both of, you might be the most knowledgeable person in the whole world when it comes to combining them. So you've got some topic ideas. Find some conferences to attend, consider dates, locations, themes, the communities they build, pick a few to apply for. Write a talk abstract that gives context for your idea and asks the questions that your talk will answer. Submit it a lot and you'll get rejected a lot, but keep those rejections with pride because every rejection is a time you dodged a bullet. By denying your talk, the committee prevented you from speaking to an empty room or an uninterested audience. So keep on applying and eventually you get accepted. What have you signed up for? But if your abstract asks a bunch of questions, their answers are a pre-made outline for your talk. Arrange the answers to tell a story with a beginning, a middle, and an end, add context so the audience can understand, and practice with a stopwatch to see how long it'll take. If it's too short, add more content. If it's too long, you cut something out. Then you gotta make slides. Don't be scared to draw them yourself. If XKCD can draw stick figures and become an icon of nerd culture, you can draw a picture for a slide. Draw faces on stuff, whether or not it's supposed to have faces, if you want the audience to imagine how it feels. Your audience has a bunch of human brains in it, and most human brains have this huge thing for faces. They're kind of weird that way. So try not to just read text off of your slides if you can. Show pictures of what you mean, because your slides are like this camera that documents what's in your head when you think about your topic. If you need suggestions for how to communicate in pictures, look at how the movies and the TV and the art like comics do this. All of them arrange these visual representations of concepts onto screens just like you're going to try to. So you've got content, you've got slides. Now practice and get feedback. If your friends want to help you, they can listen to your rehearsals and tell you what they thought. And make sure to listen to your own recordings, even if your voice does sound really weird when you play it back. So you get to the conference and you do the talk just like you practiced. And then somebody asks you a question that you don't know the answer to yet. This is terrifying because you think they'll find out how little you know, and you just want to sneak away back to your room and just check the docs for the answer to that question that you know you should have remembered. But that right there is your answer. You tell them where you would look or who you would ask to answer what they asked you. And this solves the underlying problem, which was that they didn't previously know how to find out. So everybody who had the same questions as your abstract and came to your talk has learned something because you delivered on the promises that that abstract made. The audience and the organizers are happy because they learned about the thing that you shared with them. And the people who loved your talk will come tell you so. And if anybody didn't love it, they just won't say anything because they're polite. So even if it did go so well, everybody cheers for you at the end. So you should speak.
Thank you, Emily. Thank you. Do your instructions also work for people who aren't kangaroos? Yes. Cool. So if you are not a kangaroo, you can also speak. So if you're a stick figure, please also give a talk. That is the end of our lightning talks. Can we please have a round of applause for all 11 of our presenters today, including 5 presenters today who delivered their first ever conference talk. If you haven't given a conference talk, you should speak. There's a separate bucket on the Regio desk for people who haven't given a talk at the conference so that we can know that you're somebody who hasn't given a talk at the conference and give you a great opportunity to give a talk in front of a really welcoming audience. So that's the end of the lightning talks. Time to hand over to Katie, who's going to close out the day of the conference.